Hi, and welcome to the pre-recorded video presentation of our paper, Congolese Swahili Machine Translation for Humanitarian Response. My name is Alp, and I'm here representing the work with my colleagues Eric DeLuca, Rodrigue Bashizi, Eric Paquin, and Grace Tang, all of Translators Without Borders. So, what can you expect from this short video? I'm going to start by giving a short background on the language that we're working in, Congolese dialect of Swahili. Next, present the data that we sourced and created for this work, our methodology and experiment in order to obtain the machine translation models, the results of these various experiments, human evaluations that we performed in a real use case setup, and finally, some notes on reproducibility. So, Congolese Swahili is the dialect of Kiswahili spoken by roughly 9 million people in Democratic Republic of Congo. We see some support for Swahili in commercial machine translation. However, this dialect differs quite a lot in terms of vocabulary, grammar, and structure, which is largely caused by difference in educational politics and the colonial languages of the various countries it is spoken in. So just to illustrate this difference, here's a sample sentence taken from a Ebola context translation. Once the test is negative, the family can take care of the funeral themselves. Even to a non-speaker, like me actually, the first thing that you notice is the length of the translations, right? This is, for example, because the word negative cannot be translated to one word, like in the coastal translation, but it has to be translated into something like, if the test shows that someone is not sick. Why? Because basically the word negative is not commonly used at all and is not known in the Congolese dialect. For example, caring for a funeral also doesn't really mean anything. So a colloquial word, kufanya, is used instead of the word for care, kushugulikia. So this kind of hints that a machine translation engine solely based on the coastal dialect translations would be kind of ineffective in delivering and receiving sensitive information like this. So that's why we embarked as Translators Without Borders to build a dialect-specific machine translation engine to aid the humanitarian relief efforts in Democratic Republic of Congo. So, parallel data is the main ingredient of machine translation. This is essentially a set of sentences with their translations. To build a bidirectional Congolese Swahili to French model, we needed access to translated data in these languages. So we sourced handcrafted parallel data in this language pair from 3 sources. First, the Gamaim kits. These kits consist of sentences originally sourced from Tatoeba, which means general domain sentences, day-to-day language. We took a portion of that set and translated them manually to Congolese Swahili. For this work, we present a set of 25,000 sentences and shared them publicly in our project portal. Next is TICO19 dataset, which is a set of 3,000 sentences, however, in COVID-19 domain. This is also publicly available in the project's page. And finally, some 500 sentences that were taken from our in-house translations, basically from translation requests done for NGOs that assist in the humanitarian relief in DRC. Of course, this data wouldn't be enough at all, so we sourced all the data publicly available. The only data set available for Congolese Swahili was the JW300 set. These are like Bible and general domain sentences, however, a good amount, like 500,000 sentences. We also supported with data from Swahili, coastal dialect, both paired with French and English. So to make use of the data paired with English, we took the English part of these sentences and translated them automatically to French using an off-the-shelf translation engine. It is also known that a technique to improve machine translation in low resource settings is back translation. This is taking monolingual data and converting them to the interested language using a machine translation model. So we sourced 766,000 Swahili sentences from Wikipedia and news sites and translated them to French using a model created in this work. So our methodology in a nutshell is demonstrated in this diagram. We first make a base model using all the data available. Coastal dialect, Congolese dialect, from any domain, using both authentic and synthetic parallel data to make a base model. Next, we fine-tune on the dialect using the data that we know are in the Congolese dialect. So our in-house sets plus the JW300 data set. And finally, we fine-tune it on our handcrafted data sets, which we are sure that are high quality and in the dialect that we are interested in. And finally, we evaluate on our test sets. In order to test the improvement that we get from these different data sets and so on, we have defined 4 procedures for experimentation, each procedure having a different data set mixture for using in the base model, but at the end, finally, always fine-tuning into our data sets. So in the left side of this slide, you see different data mixtures, which include, for example, the monolingual data mixture includes the monolingual data, but also all the other data. And the machine translated is the pair converted data set that we have, that we converted from English to French, Swahili data mixture, Congolese Swahili data mixture, and TWB data mixture, which is the handcrafted data. So 4 procedures. First of them is only uses Congolese Swahili data. The second one, we use Swahili data and do cross-dialect transfer learning. On the third one, we use machine translated data. And finally, we use the all synthetic data that we have. So how does it look in terms of blue scores? For each procedure, we have tested in 2 different sets. The TWB kit, the Gamma-in kits, consists of 1,000 sentences taken aside from training, of course, and 500 sentences from the TICO19 set. So comparing procedure B to A, what we see, this is inclusion of coastal Swahili data. We see an increase in quality. For Gamma-in kits, we see Swahili to French direction 1.5 and French to Congolese Swahili direction 1.8 blue points increase. For TICO19, this is 1.7 and 2. Going to procedure C, including the pair converted data, we obtain another 0.4 points increase in kits and 0.7 in TICO19 data, however, only in the French to Swahili direction. And finally, we see that the back translated data only improved in the TICO19 set, obtaining 20.1% blue for Swahili to French direction and French to Swahili 16.5. So, of course, automatic evaluations is a metric that is really helpful. However, it is essential to evaluate the quality of a machine translation system manually in order to assess its usability in real-world scenarios. So we designed some manual evaluation experiments in order to give us insights on how our models would perform in the context of a COVID domain chatbot. Uji, it's how it's called, is TWB's chatbot deployed in DRC, answers questions and records concerns and feedback related to COVID-19. It speaks in French, Swahili, and Lingala. You can interact with this bot actually following this link, and you see our co-author Rodrigue interacting with the bot. So this project actually gives us two main translation tasks. First is the translation of professionally curated responses to common queries related to COVID-19. This is originally French content and needs to be translated to Swahili. Second is the analysis of queries coming from the users and complaints and so on, for example, in Swahili, and we need to monitor them in French. For the first translation use case, we use a post-editing setup. We selected 10 recently prepared response strings, originally prepared in French. We translated them using our engine and asked a linguist to post-edit that. We saw a high correlation between the post-edited versions and the machine-translated versions. Both you can see, for example, in this example, the edits made by our linguist, and also the blur scores comparing these post-edited and machine translation output shows a high correlation as well, 55% blur. So next is we use direct assessment in Swahili to French direction. We collected 100 Congolese Swahili strings coming to the chatbot and translated them using our engines and asked two translators to evaluate them. The questions were, how good is the translation on a scale of 1 to 10? And secondly, does this translation convey the mean meaning of the source text? We got a 6.3 out of 10 score with a standard deviation of 3 for the first question. And in our second analysis, we saw that at least some of the key message of the source text was coming across 75% of the time. And in 48% of the strings, actually, the evaluators both agreed that the key message was being conveyed. So the data and both the models created by this work are open sourced in our project portal, our training pipeline as well in our GitHub page. And also we made demo translator application available as well. So that was it. Thanks a lot for listening. So since we cannot interact after this video, if you have any questions or feedback that you would like to tell us, please don't hesitate to contact. And thanks a lot.